This video will serve as a tutorial for the TinkerCad software for the Embedded Systems Lab. The first thing you're going to want to do when you go to the TinkerCad website is to create a profile. You can simply sign in with the Google or any other email address, and this will allow you to create the account. You don't need a password or anything, just an email address. Once you sign in, you're going to want to go over to this tab and click Circuits, and then Create New Circuit. You may notice some tutorial features that will pop up, but we won't be using any of them today, so just X out of them. First, we want to take the two major components we're going to be working with and drag them over. We're going to be working with an Arduino Uno, right here, and a breadboard. So once you click on it once, you'll start seeing it carried around by your mouse, and then you can click on it again to drop it. Using your scroll mechanism, like a wheel or a trackpad, you can zoom in and out. And when we click on something, we notice that they may have a window that will pop up. And we can give them a name, although you won't need to be doing that today. And you'll notice for some other features later, we'll be able to customize them, such as by adding, changing the color of an LED or changing the value of a resistor. So also a few other features you should know about here. Oh, that's a wire. I'll just start with that. When creating a wire to connect two different things, if a wire can be connected, you'll hover over it and you'll notice this red square that will appear, as well as the label of the pin. So if I click on it, a wire will now be coming from the place that I've clicked initially. If I click somewhere else with a red square, I can place a wire, which now has a name. I can change its color. Oh, gray can't be seen. Just you can see that red. And you can see it's connected. To check connectivity, you can look for these green highlights that appear. Anything that's green is connected to the pin you're hovering over. So I can see this entire column here is connected, and this entire row here is connected. So from this wire, if I follow it, it comes from pin 10, and this entire row is now connected to that pin through this wire. If I wanted to connect it to these two are not connected, so if I wanted to connect these two rows together, I'd put another wire. Now you can see that there's a path for current to flow. If I don't like the orientation of one of these objects, I can rotate it using this menu up here. This is the rotate bar, and if I simply click it, I can rotate my device clockwise. This works for anything, so I can do that with the Arduino as well. And the wires will stay connected, since it's not like real life. The wires can just stretch as they need to. That's pretty cool. Now, let's look at this menu, because most of the devices you'll be using come from here. The resistor is at the top, and this is probably the thing you'll be using most commonly, as does the LED. We'll take a resistor out, just place one here. I can change the resistance value, as you can notice. Here, I can put a simple value in here, and I can change the measurement from this menu. Pico-ohms, nano-ohms, micro-ohms, milliohms, ohms, kilo-ohms, mega-ohms, and giga-ohms. Depending on what you're working with, you may be told what resistance value to use. Generally, this omega, which means ohms, is on the smaller side and usually what you want to work with. So maybe 500 ohms for a lot of your labs are pretty much the way to go. And you'll know that they successfully changed the value of the resistor, the color changes, and if you bring up the box, you see the new value here. Much like before, we can rotate it just the same way. And now to connect, we have two options. We can place it, and you can see that this just kind of automatically snaps into place, like so. Or I could ignore the breadboard, and I could just use the terminals here, and I could just connect it with a wire. So it'd be up to you whether you wanted to use the wires or the breadboard itself. So in that sense, you don't technically need to use the breadboard if it's exceptionally confusing, although we find it's helpful to get a sense of how everything connects, but you could just connect everything purely with wires here in TinkerCad. If I want to delete something, you can use the delete key in your keyboard like I've been doing, or once you clicked on it, you can go up to this garbage can, click it, and it will disappear. To be thorough, I'll also show the LED, which we'll be using today. And you'll notice instead of a resistance value, we will have a color that will pop up. So you can change green, yellow, you get the idea. Also with the LED, we know that the direction of the current matters and the way you connect it matters. When you hover over a leg, it'll label it a cathode or anode. We don't mention this in the lab, but the anode is the positive end, and the cathode is the negative end. That's another way for you to keep track of whether the LED is connected in the right direction or not. These are all the devices that you'll be using in this particular lab, but as you can see, there's a good menu of other things that you may want to investigate when you've finished. There are plenty of tutorials online that explain how these work in detail, but we just want to give you a taste of what you'll be working with this lab here today. If you're confused about the traffic light construction at the end of the project, there will be a separate video showing a demonstration of how to construct it and what it should look like. Until then, enjoy the lab.